In this video, I'll show you how to solve the ALEKS problem called identifying oxidized and reduced reactants in a single displacement reaction. Let's start with some definitions. First of all, oxidation is defined as the loss of electrons. One example of oxidation would be an atom, which is neutral, losing some electrons and being converted into a cation, which is positively charged. The reduction process is literally the opposite of oxidation. It is defined as the gain of electrons, and an example of reduction would be the opposite of the example that I provided for oxidation. So a cation gaining some electrons and being converted back into an atom. Now I do want to point out that these things that I've listed here are examples of oxidation and reduction. There are many different types of oxidation and reduction. These examples apply to this particular ALEKS problem, but these examples are not going to apply to every single homework problem that you might encounter. So for this ALEKS problem, we're going to be focusing on these two examples or definitions of oxidation and reduction. Let's take a look at this first balanced equation. To find my oxidation reaction, I am looking for a reactant that is an atom, boom, there it is, being converted into a cation. Right there. This guy. Ooh. This guy right here. Remember, in an ionic compound, the first substance that's listed is the cation. The second substance that's listed is the anion. We know, without even looking up the charge on this magnesium ion, we know that this must be a cation because it is listed first in the formula of the ionic compound. So this magnesium is meeting the definition of oxidation. It is our reactant that is being oxidized. Now, what about the reactant that's being reduced? Well, first of all, the other reactant is always the one that is being reduced. In any oxidation reduction problem, one reactant is oxidized, the other reactant is reduced. So you really only need to find one of them and identify one of them, and then you automatically know the other. You're never going to have a situation where both are oxidized or both are reduced. So, but let's just kind of carry through with this anyways. The definition of reduction is a cation being converted into an atom. So a cation on the left-hand side of the arrow being converted into an atom on the right-hand side of the reaction arrow. And again, I know that this is a cation because it is first in the molecular formula. Let's practice with the second equation. First of all, let's look for our oxidation. The oxidation is the atom being converted into a cation, and so that is our zinc. And the reduction is a cation being converted into an atom. And notice that when I'm writing the reactant that's being reduced, I'm writing the whole entire ionic compound, the whole formula. I'm not just writing the iron, I'm writing the whole entire reactant. Last but not least, let's look for our oxidation. The oxidation is the atom that gets converted into a cation, that is magnesium again, and the reduction is the cation that gets converted into an atom. We're going to write the whole entire ionic formula, AgNO3. It's not necessary to, and it's actually wrong, it would be wrong to include the stoichiometric coefficient, so leave those out. ALEKS, however, it does not require you to include states in this answer, so I'm not writing any of the states over here.